So let's assume that the amount of drug in a bloodstream is given by d of h equals 37e to the negative 0.19 h. So d must be amount of drug and h must be number of hours. How much is left after 4 hours and how much is left after 8 hours? Okay, so this problem is just essentially asking us to use the model to predict how much drug would be left inside of the body after a certain number of hours. So in blue, we want the amount of drug, D, that would be left after H being 4, or 4 hours. So in other words, we want to calculate 37 e to the power of negative 0.19 times 4, because we're letting H take the role of 4. So I'm just going to grab a calculator here, get 37 e to the power of, making sure everything's in the exponent here, negative 0.19 multiplied by the number 4, and it looks like there are, to one decimal place here, 17.3 milligrams or whatever the units are left inside of the bloodstream after 4 hours. So what would change for the 8? Well, that would just mean that we want D, the amount of drug, but we want how much is left after 8 hours. So same model, 37e to the negative 0.19, but instead of multiplying 4 this time, we're going to multiply 8 because it's asking after 8 hours. So 37 e to the power of negative 0.19, we're expecting this to be less, right my friends? Multiplied by 8, is it going to be half as much? No, it's going to be a little bit less than half as much. It looks like it's 8.09, so 8.1 rounded to one decimal place of accuracy. So this exponential decay function is decaying, but it's not linear, so it's decaying at a different rate than a linear function. It's not a constant rate. Okay, why don't you try this next problem on your own? The amount of uranium in a sample is modeled by A of t equals 3200, 1/2 to the power of t over 14. So A is the amount of uranium and t is the amount of time, presumably in hours here, because the question's asking about hours. So how much is left after 10 hours and how much is left after 20 hours? That 14 in the denominator in these kind of radioactive decay problems is often referred to as a half-life. So 10 is less than a half-life and 20 is more than a half-life. So as you're starting to think about this problem, we're kind of expecting the first answer to be more than half of 3200 and the second one to be less than half of 3200. Let's see if our intuitions hold true here. So A of, in the first problem, 10 hours is going to be 3200 1/2 to the power of 10 over 14. So I'm just grabbing my calculator and going 3200 parentheses 1/2 to the parentheses 10 divided by 14, and I am getting 1950.4218, so let's go 0.4. So notice half of 3200 is 1600, so this is definitely bigger than a half. Bigger than half. On the other hand, in green, what is the A of 20? How much is there left after 20 hours? That would be 3200, 1/2 to the power of 20 over 14. So again, 3200 parentheses 1/2 to the power of 20 over 14. This time it's 1188.795. So we'll put 0.8 as rounded to one decimal place. And yes, that one is less than 1600. So everything was just like we thought it should be.